And here's what the phone call was about this morning. Evidently, the administration is beginning to panic. Evidently, spring registration is very slow and low. So what the phone call is about this morning is they want department chairs, well, they want all faculty on campus next week, Monday through Thursday, and when they're not in class, to be advising students. Well, they have a virtual advising center that was supposed to be working, I thought, quite nicely, but evidently students aren't using it. And if students don't use the virtual advising center, then they may or may not be able to register for classes. I don't know. This is this new system banner. It stinks. It's a terrible system, but that's what the Montgomery wanted us to use. And evidently it's not doing too well. So now they're going to force us all to be on campus. I can't be there because of my health, and they understand that. But they're forcing all other instructors on the campus. These are instructors who have had COVID and may still, I don't know if they're still, it's just absolutely nuts. Okay, they're not teaching on campus, but they're supposed to be on campus. Students shouldn't be on campus in my mind either, but I don't know if they're requiring students to go to campus to, I just don't know. I'll find out more at the meeting this morning. But anyway, here's what I suggest to you. Register today. Register tomorrow. Register Thursday. Register Friday. Get yours done before all this big push starts next week. Now, if you need to go to campus, okay, and register there next week. Okay, I don't know where they're doing it on the Birmingham campus. Maybe out in the hallways like they used to. That sounds kind of crazy, but they may be at the Student Success Center. I think they have a lot of space there. On the Bessemer campus, it's going to be, I think, in Ethel Hall Auditorium and in one of the Jess Lanier big computer rooms. Okay, now, so if you don't know where those are on the Bessemer campus, but you do know where Birmingham campus, I think it's in the Academic Success Center, go there. Okay, but if you can, get it done before then. Get it done before they get into all this big push, and therefore get it done. I don't know. I don't know what the trouble is. I don't know if virtual advising is not working. It worked quite nicely, I thought, last summer for fall. Everything seemed to work. For some reason, things aren't working now. I don't know why. So anyway, if you can, please register for spring term the soonest you can possibly do so. Sign up for virtual advising, do whatever it takes, try to get registered for spring. Okay? Any questions?
Professor Fellow, I just need to let you know that James Flynn is at the doctor.
Okay. Alrighty. I hope it's not COVID, is it?
No, sir, he hurt his ankle yesterday.
Oh, I see. Okay. Okay. I hate that he hurt his ankle, but I'm glad it's not COVID. I have another baseball player in one of my calculus classes who had COVID, but he had a very mild case, so I was just hoping that hadn't happened. But hope his ankle gets better. All right, any other questions? But thanks for letting me know. See, I didn't know is James also a baseball player?
Yes, sir.
Okay, so you, Jared, and James, right?
Yes, sir.
Okay, good. How are the season going so far?
Our fall season ended. We did all right, but the spring season starts in February.
Okay, all right. Well, hope you do well. Okay, so let's. Are there any other questions, issues, concerns? Okay, where we are. We're in Chapter 5, Analytic Trigonometry. We're right at the end of Section 5.3. Okay? If you got your books or ebooks or whatever, we're on page 368. At the top of the page was example 9 that we've already done, and we're getting ready to do example 10. However, this is not on the 5.3 PowerPoint, so I don't even have those up. So we're going to do those on the whiteboard. So here it is. Find all the solutions for this equation. Okay? Sine, if I can get my pen to show up here, sine squared x. I found out I have to write really slowly so the pen can cooperate well. Minus 3 times the sine. See there, it's not cooperating. Sine of x. Okay. Minus 2 is equal to 0. Okay. And this is on the interval 0 to 2 pi. That's 1 period for sine. Okay. Now, how do we proceed with a problem like this? Well, we would try to factor it if we could. Well, the only possible factorization for sine squared would be sine times sine. Okay? And the SIGN sign of the last term is a negative, so one of these would be a plus and one's a minus. And the only factorization for 2 is 2 and 1, but with one being positive and one negative, there's no way you're going to get a minus 3 out of that. So we cannot use factoring in this problem. Try it to your heart's content. You will not be able to factor that. So since you can't factor it, we're going to use the quadratic formula. But remember, the quadratic formula is usually for a variable squared minus something times a variable plus or minus something else is equal to 0. Now we use the trig function rather than the variable. So here's how it would work. Sine x, that's the trig function, is equal to minus b. Well, okay, your a here is the coefficient of that first term is 1. B is the coefficient of the second term, which is minus 3, and the pen is acting crazy again. And the C is equal to the third term here, which is minus 2. If I stop and go really slowly, the pen doesn't get confused. Okay, so what is that sine x equal to? Minus b, well, b is a negative 3, so minus b would be 3, and now it's not writing at all. This is the craziest system. 3 plus or minus the square root of, now maybe I should have written this down before. Do y'all all remember the quadratic formula, or should I write this down for you? Someone let me know. Anybody? Normally what the quadratic formula, someone gonna answer? Okay, normally what the quadratic formula would be x is equal to minus b plus or minus the square root of b squared minus 4 ac divided by 2a. That's the quadratic formula. So our b here was a negative 3, so minus b would be the positive 3. The pen is just jumping all over the place. Plus or minus b squared, well, b is negative 3. Negative 3 squared is 9. Now, minus 4, that's always there, times your a, which is 1, times your c, which is minus 2. Okay, and that's all divided by 2 times a, and a is 1. Now, normally I don't write all that down, but we can. It doesn't hurt anything. So that's 3 plus or minus the square root of 9. Now the next thing I do is count the number of minus signs. That first one's always a negative, but we have a positive and a negative there, so that's 2 minus signs. That makes this a plus. And 2 times 4 is 8. Okay, and that's divided by 2 times 1 is 2. Okay, well, that's equal to 3 plus or minus the square root of 17 over 2. Okay? Now, let's pause for just a moment here. Okay? Obviously, 3 is a positive number. Okay? If you added to 3 the square root of 17, square root of 17 is something a little bit greater than 4. So that'd be 3 plus 4, or something a little bit greater than 4, divided by 2. Well, 3 plus 4 would be 7, divided by 2 would be something a little bit greater than 3.5. Sine is never a number greater than 3.5. So we're going to throw that one out. Let's talk about the next one. 3 minus something a little bit greater than 4. That would be something a little bit less than a negative 1. Okay, remember, because you're subtracting. And a negative, something a little bit less than negative 1 divided by 2, that's going to be fine. So we're going to only use the minus here. The plus will not work. Does everybody see why that's the case? Because the sign always is something between plus or minus 1. Always. Okay? So let me pull out my calculator, which I happen to have sitting here. I'm worried about this pen because it's a very expensive pen and I don't want it to roll off and fall. And I also okay, so let me get my phone calculator lit off here. Okay, so I'm going to do 3 minus, because I know the plus is not going to work, and then I have to turn my phone sideways to get it in scientific calculator mode, and do a 17 and then do a square root. My phone, I have to do it that way, but it didn't do anything. Why will, oh, there it goes. Equal, and that's a negative 1.123, so that's a little bit less than negative 1. Divide that by 2, equal, and then do an inverse sine of that number. Now, on my calculator, on my phone, you see this second key over here. If you don't have the same type of phone, you have something like that. Right now you see sine, cosine, and tangent down here, not inverse. If you press the second key, now they've changed to inverse sine, cosine, and tangent. So I want to do the inverse sine of that number we have there. Now, I'm in radian mode. Let's see what they want us in. I think they want us in radian mode. So I'll do the inverse sine of that, and as far as I could tell, nothing happened. There we go. No, I'm sorry, it did happen. I just didn't recognize it. I've got to back up and try it again. Okay. So let me try this again. 3 minus the square root of 17 equal, divided by 2, equal, and then do the inverse sine. There. Negative 5.59621, blah, 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 blah. And that's what they've got in the book too. Okay? So does everybody see how that happens? Okay? So what I have then is this is approximately equal to, because this is not exact, it is approximately equal to, in radians, negative 0. I would say just negative 0.6. There's no reason to give that many significant digits. Okay, now, that's in radians. Okay, if you picture this as a sine function, okay, All right. Remember, sign goes from +1 to -1. Okay. Now, this is 0 at 0, and at pi halves, it's 1. Okay. At pi, it's it's 0 again. Okay. At 3 halves pi, 3 halves pi, for some reason I wrote 2 halves pi, it's -1. And then at 2 pi, which is as far as we're going, and we're not actually going there, it's back at 0 again. Okay. Well, the one that we found was a negative, which is over here. Here is negative pi halves, and that would be at -1 here. Now, pi halves is something approximately -3/2, because pi is 3.14, so it's close to that. Okay, so -0.6 would be something, half of 1.5 would be 0.75, so it's something maybe right in here. So this is where that value would be. But you see, that's not in your domain here. This is 0 to 2 pi. So basically what you do is go from here to there, to there, to there, and then carry this one over, and this would have gone down to here, and that would be the value. So you carry this over to here or to here, because this is 2 pi. I don't know why I wrote over 2 pi. Now, so how do you get these two values over here? Well, you add 2 pi to this one. Okay, so this is plus 2 pi, and that will give you exactly this value right here, because you see that is exactly 2 pi away from there. Now, how do you get this value right here? Okay, well, this minus 0.6, that's here, what you do is add that to pi. So that would be pi plus 0.6. Okay, the same reference value angle that you had here, you add it to this one here. So these are your two answers: minus 0.6 plus 2 pi, or pi plus 0.6. Okay, now that's using all your knowledge, maybe hopefully not all your knowledge, of how you get these to work. Okay, but this solution here, the one we got, negative 0.6, this one, is not in your domain up here. So add 2 pi to it, and it is in that domain, but you have one more, and that is pi plus that same value, that same reference angle here. You now add it to pi rather than subtract it from 0. Okay, so that would give you pi plus they put 0.5963, and 2 pi minus, yeah, you add 2 pi to the negative 0.5963. So basically the key here, know your graphs, know how to do these. Okay, your calculator will never give you answers out here, because the inverse function is only defined from minus pi halves to pi halves, because that's the place where this is a one-to-one function, the only place where it is. Your two answers were over here between 0 and 2 pi. They had to be negative. They couldn't be back here where this one was, and they certainly weren't here where this is positive, so they had to be here and here. This one is easy, just add 2 pi to that one, and this one's not too bad. Add the positive value here to your pi. And that's my drawing. Here's their drawing, if I can find it here. Yeah, there you have it. The answer you're given with your calculator is this one down here, but your domain is between 0 and 2 pi, which is over there. So you have to extend the line across, and that gives you those two values. So you see, you can't always trust your calculator. If your problem says they want the answer on 0 to 2 pi, the answer they gave you your calculator was only this one, and it'll only give you one answer, okay? But that's not between 0 and 2 pi, that was a negative number. So add the 2 pi to it, and you get that value, and then add the positive value of this, the reference angle here, to the pi here, and that's how you get this value, okay? So here's the pi plus 0.6, and here's the negative 0.6 plus 2 pi. Does that make sense? All right. There is a checkpoint after every problem. Please do the checkpoints. They will refresh in your mind and reinforce what we've just done. And that's what the student was asking. Here we are in November, and she said, I don't know where the checkpoints are. I don't know where your homework exercises are. Can I do WebAssign? I've been telling her all term, yes, you can do WebAssign, no problem, do it, you know. But she still had questions about it, and then she found out today that WebAssign and the ebook are different things. So please, I hope you know the difference and are taking advantage of all the tools at your disposal. Now, the next example, example 11, is on page 369, the top of the page there. Now, they give you a formula, the surface area of a honeycomb cell, and they give you a function, and that function has 6hs plus 15 or 1.5 s squared times root 3 minus cosine theta divided by sine theta, and they want the answer in theta, something in degrees between 0 and 90 degrees. Okay. Now, they give you dimensions. The h is 2.4 inches, the s is 0.75 inches. Theta is the angle shown in the figure, which is not particularly easy to follow, but you can see it there. What is the value? They plug all that in and then say you have to use a graphing utility to do it. There is no way in the world you can solve that equation analytically, okay? That equation right there, there's the figure, there's the angle. You have to put it in a graphing calculator. I don't have a graphing calculator, certainly not with me here. All I've got my telephone. It does wondrous things, but it will not do graphing calculator. So we're going to skip that one. If you have a graphing calculator, by all means follow it through and make sure you understand it. The checkpoint probably also requires a graphing calculator. I can't swear that it does, but I'm guessing that it does. Okay, so that finishes 5.3. There's a little summary at the bottom that's always worth looking at. Let's go to the vocabulary at the top of page 370. 4 fill-in-the-blank questions. Number 1, when solving a trigonometric equation, the preliminary goal is to blank the trigonometric function on one side of the equation. What in the world do you think they mean there? To blank the trigonometric function on one side of the equation. Well, what if you were solving an algebraic equation? The preliminary goal is to blank the variable on one side of the equation. What would go in there? Okay, I think the word they're looking for, it certainly would be the one I would use, would be to isolate the trigonometric function on one side of the equation. Get everything else on one side and go from there. Isn't that what we did in this one that's on your screen? Oh, wait. Here's someone trying to come in. Damien is here. So let me get Damien here. Damien's right below the blue line here. All right. Turned out to be a pretty good attending class today. Way to go, team. Okay. Now, so that I think is what they're looking for there. When solving a trigonometric equation, the preliminary goal is to isolate the trigonometric function on one side of the equation. Move everything else, just like we did here. Now this we were using the quadratic formula, but what did we do? We put the trig function here and all the numbers over here. Now that's not quite the fair way of doing it. It looks like somebody is either sending a message, a chat, or something. Is anyone else trying to get in the classroom? I don't see. Okay, there should be 13 students. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Actually, we lost somebody, so maybe that's what was clicking before. All right, any questions? Okay, I'm going to minimize that. Okay, number 2, vocabulary question number 2. The blank solution of the equation 2 sine theta plus 1 is equal to 0 is theta is equal to 7/6 pi, or 7 pi over 6, either way you want to say it, plus 2n pi, and theta is equal to 11/6 pi plus 2n pi. What is that solution called? The blank solution. Okay. If you go back early in the section, 5.3, in that introduction on page 362, you'll see in that first paragraph there, the first answer, isolate the trig function on one side of the equation. That's the one we just answered. Okay. Now the one they're asking now is those two solutions are called the general solution. There it is, the red type right below that paragraph, or a little bit below, the general solution. Perfect. Okay, number 3. The equation 2 tangent squared x minus 3 tangent x plus 1 equals 0 is a trigonometric equation of the blank type. Now, I just had another thing pop up here, and we've lost another student, it looks like. So we're down to 12 students in the class now. So hopefully some of those are coming back. So what is the type of that equation? The equation 2 tangent squared x minus 3 tangent x plus 1 equals 0 is a trigonometric equation of the blank type. Okay. Now if you turn to page 365, the title at the top of the page is equations of the, oh, here's Kelly. She must have gotten bumped out and is coming back in. So I've already got her present. Got it. Okay, hopefully she's back now. Okay, was there somebody else trying to get in? Let me go down and see. It's kind of been crazy all day. Okay, I don't see anyone else waiting. Okay. I don't know if internet is unstable. Mine seems to be good, but it may be where you are, there are some problems. Okay, the answer to number 3 was, anyone come up with it? Equations of the quadratic type. Perfect. Okay, and number 4, a solution of an equation that does not satisfy the original equation is an blank solution. And that basically comes out when you have a when you've squared both sides, that will often happen, and you have to watch out for those. Anyone know what that term is? And the little article "and" suggests to you it needs to start with a vowel. I'm trying to find it, and yeah, there it is. It's on page 366. It says, because you squared the original equations, you check for what kind of solutions? Starts with a vowel. Extraneous solutions. Anytime you square both sides of an equation to help solving it, you may introduce a solution that's really not a solution, because when you square both sides, you may wipe out a sign, and that sign, without the sign in there, it looks like this is a solution, but it's really not. So those are called extraneous solutions. All right, homework exercises then would be any of the odds 5 through 9. They're all at Calc Chat. Any of the odds 11 through 27, they're all at Calc Chat. 13 is also at Calc View. This is beginning on page 370, and it'll go to 371, 372, and 373. So there's quite a few of them. So any of the odds 29 to 37, they're all at Calc Chat. 29's at Calc View. 39 to 45, they're all at Calc Chat. 39's at Calc View. 47's at Calc Chat. Any of the odds 49 to 57 are at Calc Chat. 59 through 69 are at Calc Chat, 61 being at Calc View. 71 or 73, both at Calc Chat. 73's at Calc View. 75 or 77, they're both at Calc Chat. 79 through 83, they're all at Calc Chat. 85's at Calc Chat. 87's at Calc Chat. Well, I'd say any of the odds 87 through 95, I believe it is, should all be at Calc Chat. 97 should be at Calc Chat. 99's at Calc Chat. And either 101 or 103. There is a little blurb, not quite a blurb, something like that, at the bottom of page 373 on a project on meteorology. If that's something that's of interest to you, then you might want to pursue that as a paper topic. Hint, hint, okay? Now, I failed to mention this at the beginning. Let me mention it now. For those who have come in a little bit later, they are making an enormous push to get spring registration up. Right now, it's pretty paltry, it seems to be. I'm not on campus, so I can't see. This new system that we have doesn't allow me to see very much. But anyway, evidently it's pretty low. So what they're doing next week is having all faculty members go onto campus all 4 days, Monday through Thursday of next week, which to me is a crazy thing to do. I can't go because of my health, and they don't want me to go because of my health, but they're making everybody else go. They're going to be teaching from their offices. They're not going to be in the classroom. They're going to be teaching just like I'm teaching now from home. They're going to be teaching from their offices, okay? Students are not to be in their offices. They're not to be in the classroom, but they're going to have them in big rooms for advising, okay? Well, we've got the virtual advising center. Everything's right there where it should be. Why aren't they doing it there? I don't know. Evidently, the virtual advising is not working well. Well, they need to work on that rather than risk people's health. But anyway, what I suggest to you is please register now. Register today. Register tomorrow. Register on Thursday or Friday. If you want to go to campus and register, then you can. The trouble is, a faculty member cannot register you. Okay? You have to register yourself. Now, if advising is what you need, they will be available for advising. Okay? I will be available for advising in a virtual sense because I'm always on the virtual advising center. So far this term, I've had zero. Since the very beginning of the term, nobody signed up for advising. So I think there's an issue with that. I don't know what it is, but there seems to be the issue there. But anyway, please, if you can, avoid the crowd, avoid the rush, go on and get registered for spring term. Okay, please do that. Now here's the other part that I failed to mention at the beginning. I probably need to say it now. It's sort of a good news, bad news situation. Okay, the bad news is that tomorrow is Veterans Day, and in the state of Alabama, Veterans Day is a state holiday, meaning the campus is closed. There are no classes, there's nothing going on tomorrow, so don't go by campus tomorrow. Okay, no one will be there. Okay, the good news is it doesn't affect us any, does it? Because we meet on Tuesday and Thursday. So I can hear the cheering in the background that we won't lose a class. So anyway, that's the situation there. All right, let's now go back to PowerPoint. Any questions on anything I've said so far? Okay, we'll go from current slide here, and we're still in Chapter 5, Analytic Trigonometry, and there's Weston, I think, kicking a field goal. Okay, no, you were catching a pass. That was a different story. Yes.
Which week is this that we're in?
Which week are we in? Is that what you said?
Yes, sir.
I believe this is considered to be week 13, isn't it? So let's go. Yeah, let's go over that while I'm glad you mentioned that. Okay, we have class this week, both Tuesday and Thursday, because Veterans Day is on a Wednesday. Then next week we have classes Tuesday and Thursday. The following week is Thanksgiving week, and if I'm not mistaken, the school is closed for students on Thanksgiving. We're going to have professional development the Thanksgiving week, at least Monday, Tuesday, and Wednesday, but students, there are no classes Thanksgiving week. Thursday and Friday, of course, the school is closed. Okay, that's Thanksgiving holiday. We come back after Thanksgiving for one more week of class. That's the first week in December. And on that day, I will be giving you, on the Thursday of that week, I'll be giving you your final exam. You're to turn that in sometime during the following week, which is final exam week. Does that make sense? Okay. All right. Is that sort of what you were asking? Okay. So this week is week 13. Next week is week 14. Then Thanksgiving is not counted as a week. Week 15 is that week we come back in December, and well, actually, you don't go on campus that week, but we'll be back teaching that week. And week 16 is final exam week. So I believe that's right. We're in week 13 right now. All right. Any other questions? Good questions, by the way.
I have a question.
Yes.
I'm still working on test 2, so it's okay if I turn it in later on.
Just get it to me as soon as you can. Okay? Yeah. Perfectly fine. Get me the test. First test, second test, research paper, and I'll be getting you the third test probably, maybe even Thursday. Depends on how far we get today. Okay? So, any other questions? Good questions. All right. So, Chapter 5, Analytic Trigonometry. We're in section 5.4, we're starting now, is sum and difference formulas. Okay? Now, our objective here is to use the sum and difference formulas to evaluate trigonometric functions, verify identities, and solve trigonometric equations. This sounds sort of familiar, doesn't it? Evaluate, verify identities, solve trigonometric equations. That's what this chapter, Analytic Trigonometry, is all about. Okay? So, what are our sum and difference formulas? Okay? We've gotten, well, These are a little different from our others, so let's take a look at them. And they don't give you any verification of them, they just tell you what they are. So in this section you will study the uses for several trigonometric identities and formulas, and here's what the first ones will be. The sum formulas. What if you have two angles, u plus v? Okay? The sine of the sum of two angles, now get this one down, it's the sine of the first times the cosine of the second plus the cosine of the first times the sine of the second. Okay? That's your sum of the sine of the sum of two angles. Now, you can also have the difference of two angles, the sine of the difference. Well, frankly, notice here the u's are the same as the u's up here. So sine u is still sine u because it's the same. But here's the difference. This has a plus v, this has a minus v. Well, because sine is an odd trig function, that means the sine of negative v is the negative sine of v. So anywhere you had a sine v up here, it becomes a negative sine v down here. So that sign changes, that SIGN sign. Cosine, on the other hand, is an even function. So when you have a cosine v here, you have a cosine of negative v is still cosine of v. And cosine of u, because that's the same u here, those are the same. The sign changes because sine of negative v is negative sine of v. So that changes the sign in between. Okay? So those two are pretty easy to remember. If you can remember the first one, the second one's easy. You just change the sign. Now the cosine of the sum of two angles is cosine u cosine v minus sine u sine v. So here the plus becomes a minus. Okay? And it's not sine cosine, it's cosine cosine sine sine. And then when you change that to a minus v, the cosine minus v is the same, but the sine minus v changes. And since this was a minus up here, it becomes a plus down here. Okay. Now, this one's a little tougher. The tangent of u plus v is the tangent u plus the tangent v divided by 1 minus the tangent u plus times the tangent of v. So the sign for this is the same as up here, but opposite down here. When you do tangent of u minus v, the sign's the same up there, SIGN sign, tangent u minus tangent v, and then you flip it down here over 1 plus the tangent u tangent v. Do I memorize these? Generally, no. I look them up if I need them, especially these tangent ones, to make sure I've got the SIGNs right. The sum and differences of sines and cosines, after you use them enough, you get to recognize them. Okay? It's the tangent that you have to really pay attention to, or I do anyway, because I don't memorize well. So example 1 shows how the sum and difference formulas can enable you to find exact values of trigonometric functions involving sums or differences of special angles. Special angles is the key word there. So what we want to do is find the exact value of sine of pi twelfths. Well, that's not one of our special angles. Our special angles are 0, pi 6, pi fourths, pi thirds, and pi halves. Those are the ones we really know and love and remember well, don't we? Yes. Okay? So let me just jot those down again. Okay? Those that we know precisely, if I could get my pen to show up somewhere here. Where, oh, where are you, pen? There we are. Okay. Let's jot down what those were. Of course, 0, pi 6, pi fourths, pi thirds, and pi halves. We know the sign of every one of those, don't we? Say yes. Okay. Now, What's the least common denominator of all those denominators? Pi twelfths. This would be 0/12. This will be 2 pi twelfths. This will be 3 pi twelfths. This will be 4 pi twelfths. And this would be 6 pi twelfths. Okay? Now we know these angles. We know the sine of those angles. We know the cosine of those angles. We know the tangents of those angles. We can figure out the secants, the cosecants, and the cotangents. We don't need to, but we could for those. What I'd like to do is say, are any of these differ or sum by pi twelfths? Well, the difference between these two is pi twelfths, and the difference between these two is. This is 2 pi twelfths, so we're not going to use that, and we're not going to use that. But here's two differences. So basically what we're saying is the exact value of this would be the sine of pi fourths minus pi sixths. This one minus that one will give you exactly pi twelfths. Now we'll also get it if we did pi thirds minus pi fourths. I think that's the one the book uses, so let's us do this one. What was the sine of a difference formula? That would be the sine of pi fourths, that's supposed to be a 4, times the cosine of pi sixths minus the cosine of pi fourths times the sine of pi sixths. Because notice the sign changed here, and the sine of a negative pi 6 is negative sine of pi 6. So that's why that sign changed too. Does anyone recall what the sine of pi fourths is? Square root of 2 over 2. What's the cosine of pi 6? I think that's the square root of 3 over 2. You should know these by now. Okay, minus cosine of pi fourths is also the square root of 2 over 2. The sine of pi 6 is 1/2. Okay, and these are time signs in between these. Okay, so this will be the square root of 6 over 4 minus the square root of 2 over 4, which you could write as the square root of 6 minus square root of 2 over 4. Okay, now that's an ugly number, but that's an exact value. If you pull up your calculator and did square root of 6 minus square root of 2, you would get a decimal number, not exact, but close, because it has a whole bunch of digits, but not exact. Divide that by 4, and you again get close, but not quite cigars. Okay, that's the answer. That's the exact value of the sine of pi twelfths. Now, we did it using the difference between these two. Pi fourths minus pi 6, that came out exactly pi twelfths. Okay, the book, I think, is going to use the other two, pi thirds minus pi fourths. Let's see if they get the same answer. So I'm going to erase what we did. Does anyone need this a little longer? No? Okay. Let's see how the book did. To find the exact value of sine of pi twelfths, they used the fact that pi twelfths is exactly the difference between pi thirds minus pi fourths. We used pi fourths minus pi 6. It was also exact. This one is as well. Are we going to get different answers because we use different angles? We hope not. Okay, so what we'll do is rewrite that as the sine of u minus v, and that would be sine of pi twelfths would be the sine of pi thirds minus pi fourths. That's pi twelfths. And that would be the sine of pi thirds times the cosine of pi fourths minus the cosine of pi thirds times the sine of pi fourths. sine of u cosine v minus cosine u sine v. Okay? Now, what is sine of pi thirds? That is the square root of 3 over 2. Cosine of pi fourths times the square root of 2 over 2 minus cosine of pi thirds 1/2 sine of pi fourths times the square root of 2 over 2. This would be square root of 6 over 4 minus the square root of 2 over 4, and that would be the square root of 6 minus the square root of 2 over 4. Exactly what we got before. Okay? So let me, now if anyone's trying to send me a chat, if I pull it up, everybody's going to see it. So if you want to chat, just get on and chat. Ask the question, get it to me. If you're chatting among yourselves, that's perfectly fine. Perfectly fine. But if you want me to respond, go on and ask me, because everybody's going to hear the response anyway. Any questions? Okay, so let's see how they proceed. Just like we did, that's square root of 3 over 2 times square root of 2 over 2 minus square root of 1/2 times the sine times square root of 2 over 2, which would be square root of 6 minus square root of 2 over 4. And it says check this using try checking the result on the calculator. You'll find that the sine of pi twelfths is to the same number of precision digits what that is. Okay, they actually rounded it way short of what your calculator would. Any questions on example 1? Now, they're skipping. Well, first, there's a checkpoint after example 1. Good idea to do the checkpoints. Now, I hope in this class all of you are familiar with how to get to the checkpoints, how to use your ebooks or regular books or whatever. I was just so surprised this morning that's what the student had, because she kept asking me, can I do WebAssign? I said, sure, you can do WebAssign, whatever you want to do, And this morning it was again asking me, and she said, I don't see where the checkpoints are. I don't see where your homework exercises are. And so I went through her and I said, would you have the ebook open? Yeah, I can get it open. She said, it's not in here. It just gives you this. And when she finally said what it gave me, I said, are you sure you're not in WebAssign? She said, oh, I thought WebAssign and the ebook were the same thing. I said, no, they're not. And so she said, oh, here's the ebook. It's been here all along. So she found the ebook, she found the examples, she found the checkpoints, she found the homework exercises this late in November, and she just is finding out that information. But she's been doing well, so I hope she's okay. So that was example 1. They're skipping 2, 3, and 4, all on page 375. So let's do as much as we can of 2, 3, and 4. So let's go to the whiteboard. And we only have about 8 minutes, so I don't think we're going to get them all done. All right, to clear what we did before. Okay, example 2. I can't read it from where I'm sitting, so I've got to move it to my lap. Find the exact value of cosine of 75 degrees. Well, 75 degrees is not one of our favorite angles, is it? What are our favorite angles? 0 degrees, 30 degrees, 45 degrees. These are the same ones as I listed before in radians. 60 degrees and 90 degrees. Same ones I did before: 0 radians, pi 6 radians, pi 4th radians, pi 3rd radians, and pi halves radian. Those are the ones. Now, are there any of those that either add to be 75 or the difference is 75? Well, the first two that pop on my screen are these two. They add to be 75 degrees. So therefore, this is the same as the cosine of 30 degrees plus 45 degrees. Well, that's the sum formula, and that sum formula is cosine 30 degrees times the cosine, remember cosine is cosine cosine, 45 degrees, minus, the plus here becomes a minus here for cosine, sine 30 degrees times the sine of 45 degrees. All right, and hopefully you know these and know them well. Okay, cosine of 30 degrees is the square root of 3 over 2. Cosine of 45 degrees is the square root of 2 over 2. Minus the sine of 30 degrees is 1/2, and the sine of 45 is also the square root of 2 over 2. These are time signs here. And when you multiply those together, guess what? This is the square root of 6 over 4 minus square root of 2 over 4, which is the square root of 6 minus square root of 2 over 4, which is the same answer we had before. Wait, what's going on here? Well, if you remembered, this was pi 6 and pi, goodness gracious, this thing aggravates me no end, pi fourths, okay? And we used the difference there before, okay? But remember, we could have done these two before. Well, let's see. Okay. Before we were doing the sine of pi twelfths, right? Pi twelfths. Now we're doing the cosine of 75 degrees. Well, guess what? 75 from 90 would be 15 degrees. Okay? Well, the difference between these is 15 degrees. So basically, we're talking about the same thing. This is the sine of the complement of the cosine. You know, pi twelfths is 15 degrees. That's the complement of 75 degrees, and this is the cofunction of that one. So of course they're the same. The cofunction of the complementary angle are the same. That was one of our identities. So we really didn't need to do the work, but we needed to do the work. So that's the example 2. There is followed by a checkpoint. Please do the checkpoints. All right, let's see if we can do example 3 before we run out of time. Okay, any questions on this before I delete it? Okay. Find the exact value of sine. I have to write so slowly to keep this from messing up. U plus V, given that, and it still won't write, sine U, it's still messing up, is equal to 4/5, where 0 is less than, I'll put an equal sign, don't need that, U is less than pi halves. So basically U is in the first quadrant. Okay, that's what this is telling you. And we're told that sine is 4/5, which means it was either in the first or second quadrant. This tells you it's in the first quadrant. Okay, and cosine V is equal to negative 12/13, where that's not 0, it's pi halves is less than v, I can't read, is less than pi. Now what that tells you, cosine is negative. Well, cosine is negative either in the second or third quadrant. It's positive in the first and fourth. This tells you v is in the second quadrant between pi halves and pi. So everything is consistent here. So we want to know what sine of u plus v is. Well, we know that. That's the sine of u times the cosine of v plus the cosine of u times the sine of v. That's our sum of two angle formulas. Well, the sine of u we know to be 4/5. We know, they told us that. Cosine of v we know to be negative 12/13. We know that. They told us that, 12/13, not 12/12. Okay? Plus, SpaghettiOs, what is the cosine of u? They didn't tell us that. Or did they? Well, if you think back on it, the sine is, this is your angle u, okay? Sine is, mine isn't drawn well, 4/5, opposite over hypotenuse. That means the adjacent side must be 3. 3, 4, 5 triangle, 9 plus 16 is 25. So the cosine of u is 3/5. Okay, times the sine of v. Well, v is in the second quadrant. Sine is positive in the second quadrant. So let's see if we can get that one done. Minus 12/13. That would be somewhere the adjacent is 12 and the opposite is 13. Second quadrant, so I think you would have to be here. So this is, wait, drawn this poorly. Let's draw it like this. This is 13 and this is minus 12. Now that's the reference angle for that one. Okay, well, what would this have to be? 169 minus 144. That would be 25. So this would be 5. So our sine is positive 5/13. Okay, so multiply these together and you get minus 48 over, I believe that's 65, isn't it? Plus 15 over 65, and that would be a minus 13 over 65. That would be the exact value of sine of u plus v. Okay, no, I did it wrong. 33. What am I doing here? 15 from 48 is 33, not 13. 1 from 4 is 3. Minus 33/65. Okay, sorry I got in a rush at the end. Now we know that the first angle here is, the sine is, the angle would be up here somewhere, and the second angle we know is an obtuse angle, so that would be here. So this is making sense. That looks like it makes sense. All right, I think we ran out of time. This is the third class I've run out of time with this morning. We'll begin next time at example 4. Homework exercises here would include any of the odds 7 or 9. They're both at Calc Chat. Any of the odds 11 through 25. They're all at Calc Chat. 21's at Calc View. I think we leave off there and we'll pick up the rest of those next time. You can maybe try doing some of 27 through 33. Okay? And you might be able to do some of 35 to 39. Let me see. Okay. And I think you can do any, and 35 to 39 are all at Calc Chat, 35's at Calc View, 41 to 45's are at Calc Chat, 43's at Calc View. I think you can do 47 to 51. They're all at Calc Chat. Hang off of those and we'll pick up the rest of those, I think, next time. Okay, good deal. Any questions? Okay, sorry we ran over, but there'll be no extra charge. I will end the recording now, so that can be winding down.